We have another example on the board. I'm going to start solving this problem from calculating the power factor. Why? Because I have given Z total and I have given R, and if I'm going to have power factor, I'm going to also find angle theta, which is needed next to Z total. Okay, so I have power factor is equal Z total over R, which is equal Z total, we have 4 kiloohms over R 7 kiloohms. Okay, this is equal 0.571. Now, please notice that we have given extra information, right, in our problem. The capacitive susceptance has greater value than inductive susceptance. So if I have statement like this, it means that my angle next to Z total is going to be negative. That's why I'm going to write right away word lead. Okay, remember, anytime we have negative angle next to Z total, I'm supposed to realize that the current, total current in the circuit is going to lead the voltage source by a certain angle. And because I have this statement, BC is greater than BL, I'm supposed to automatically write word lead next to the value of power factor. So I have power factor already. I have Z total equals 4 kiloohms, right? And I'm missing over here angle. So in order to find the angle, I'm going to write the formula which says angle theta is equal inverse cosine, and I have Z total over R. This is equal inverse cosine Z total, one more time, 4 kilo over 7 kilo is equal 55.15 degrees, and we said it has to be negative because BC is greater than BL. Okay, so I have negative angle, so I can write that my Z total is 4 kiloohms and angle of negative 55.15 degrees. Okay, I'm just separate Z total from angle theta. Okay, this is the separation line. So next, we're supposed to find the total admittance. Total admittance, Y total, is equal reciprocal of Z total, 1 over Z total. So I have 1 divided by 4 kiloohms and angle of negative 55.15 degrees. Okay, but now you're supposed to switch your calculators to the rectangular mode, and you're supposed to obtain 142.85 microsiemens plus J 205.16 microsiemens, okay? Where the real part of my answer is the conductance, and imaginary part is the combination of the inductive susceptance and capacitive susceptance. So I can say that this is my B total. So if we have B total, we can find very easy BC, right? Why are we supposed to find BC? Because I have to find the current which goes through the capacitor, right? So what I'm supposed to do? I'm supposed to realize that BT is equal BL plus BC. Now, but we do not have BL yet. So what we're supposed to do is supposed to find BL. BL is equal 1 over x of L. This is equal 1 divided by x of L is 5 kilo ohms and angle of 90 degrees. This is equal BL is 200 microsiemens and angle of negative 90 degrees. Okay, this is my BL. In order to find BC, I'm supposed to solve this formula for BC, and I'm going to have BC is equal B total minus BL, where B total is equal, we found 205.16 microsiemens, right? And angle of 90 degrees, because I have positive J, minus BL, 200 microsiemens and angle of negative 90 degrees. This is equal 405.16 microsiemens and angle of 90 degrees. Okay, so this is my BC. Keep in mind that capacitive susceptance is supposed to be always with angle of 90 degrees. So I have BC. Next, in order to find the current which goes through the capacitor, I'm going to find voltage source. Okay, because this is parallel circuit. Okay, I'm going to use Ohm's law to find the current which goes through the capacitor. So voltage source is equal I total times Z total. Okay, I'm not going to include the angles right now to my current and Z total because I want to keep my voltage source with angle of 0 degrees. So I have 20 milliamps times Z total, which is equal 4 kilo ohms. Right? So this is equal 80 volts. Okay? 80 volts. So if I want to find the current which goes through the capacitor, IC is nothing else than voltage source times BC. This is Ohm's law. So this is equal voltage source 80 volts times BC. We found that BC is equal 405.16 microsiemens and angle of 90 degrees. This is equal 32.41 milliamps and angle of 90 degrees. Okay, so this is the current which will go through the capacitor. Now we are ready to find the total reactive power in our parallel circuit. So I have Q total is equal voltage source raised to the second power times B total. This is equal voltage source we found is 80 volts raised to the second power times B total 205.16 microsiemens. Everything is equal 1.31 volt ampere reactive. Okay, so this is my total reactive power in the parallel circuit. Next, we're supposed to find the voltage across the resistor in the series equivalent circuit. In order to do so, we're supposed to simply write Z total is equal 4 kilo ohms and angle of negative 55.15 degrees and convert this to the rectangular form. Okay, you're supposed to obtain 2.28 kilo ohms minus J 3.28 kilo ohms, okay? Where the real part is my RS and imaginary part is my X of CS, okay? I have X of C because I have negative J at front of 3.28 kilo ohms, okay? So in order to find the voltage across the resistor, I'm going to find the angle which I'm supposed to have next to I total. So if I total is equal voltage source over Z total. We made the voltage source having angle of 0 degrees, and Z total we found that this is negative 55.15 degrees, okay? Next to Z total we're supposed to have this angle. So I total is equal 20 milliamps, and if you want to find the angle, you're supposed to subtract these two angles. So 0 minus negative 55.15 gives me 55.15 degrees. So it means that the current, total current in my circuit, in parallel circuit, is going to lead the voltage source by 55.15 degrees. So voltage across the resistor in the series equivalent circuit is equal I total times RS, where we have I total 20 milliamps and angle 55.15 degrees multiplied to RS, this is my RS, 2.28 kilo ohms, and this is equal 45.6 volts and angle of 55.15 degrees. Okay, you can of course draw the series equivalent circuit. Okay, so this is RS, this is my X of CS. RS we found is equal 2.28 kilo, and X of CS is equal 3.28 kilo. And this is my voltage source, and we found that voltage source has voltage of 80 volts. Okay, so next we're supposed to find voltage across the capacitor. Okay, we're supposed to find VXS. It means that we're supposed to find the voltage across the reactive component in the series equivalent circuit, but we found that the reactive component is capacitor. That's why I'm going to write that VXS is equal to VCS, because this is capacitor in the series equivalent circuit. This is equal I total times X of CS, which is equal 20 milliamps and angle of 55.15 degrees times X of CS, and X of CS we found is equal 3.28 kilo ohms and angle of 90 degrees is equal 65.6 volts and angle of negative 34.85 degrees. Okay, so this is my voltage across the capacitor in the series equivalent circuit. Next, we're supposed to find the power, right? True power. So true power in my series circuit is equal I total square times RS, which is equal 20 milliamps raised to the second power times the resistance RS, which is equal 2.28 kiloohms. So this is equal 912 milliwatts. Okay, so this is the true power in my series equivalent circuit. Next, I'm supposed to find the reactive power in my series equivalent circuit. We know that this is going to be the reactive power at the capacitor. That's why I can write also that this is QLS. And this is equal I total raised to the second power times XCS. This is equal 20 milliamps raised to the second power times XCS, and we found that XCS is equal 3.28 kiloohms. This is equal 1.31 volt ampere reactive. Okay, so this is my reactive power. So if you want to find the apparent power, this is nothing else, just I total raised to the second power times Z total, which is equal 20 milliamps raised to the second power times Z total, and Z total is equal 4 kiloohms. This is equal 1.6 volt amp. Okay, so I found the true power, I found the reactive power, but please notice that we also calculated the reactive power for the parallel circuit, and these two values are identical, so means we are doing fine. And we found also the apparent power, so we can draw the power triangle. The power triangle which we are going to draw for the series equivalent circuit is going to be the same like for the parallel circuit, okay? So we have true power, this is my P true, equals 912 milliwatts. Okay, now because my angle next to Z is negative, that's why QS, right, QS or Q total we can also call, right, is going to point down. Okay, so this is my, I'm supposed to make this a little bit longer, approximately. This one has to be shorter. So I have QS equals 1.31 volt ampere reactive, and my apparent power S is equal 1.6 volt amp, and this is my angle theta which I have next to Z total. So I don't know if you realize, but we solved the problem.